In this video, I'm going to show you two more examples of solving through our parabolas, putting the equation in standard form, and then finding the vertex, focus, and directrix. So we want to remember here we have our standard form of our equations. X minus h squared equals 4p y minus k if we have a vertical axis. And it's y minus k squared, where the y here is being squared if we have a horizontal axis. So it's x squared, it's going to be vertical, remember, so that means it's going to go up or down. And if it's a y squared, it's going to either open to the left or open to the right. So if we look at our first example here, we have x plus 1/2 squared equals 4 times y minus 1. So here we notice that we do have our x being squared, so that means we're going to fit it to this standard form here where we have x minus h squared equals 4p times y minus k. And the other thing as a reminder, make sure you're careful with, notice here you have your h and k when it's x squared, and it's reversed when you have your y squared, it's k here and h over here. So for our example, it's x minus h squared, 4p y minus k, and our equation is basically already in this particular form. The only thing we want to identify here is what is going to be this particular value for p. Well, that means this quantity, 4p, we would set equal to this quantity here that's in front of the y minus 1. Well, that's simply 4. So if 4p is equal to 4, then clearly p is simply equal to 1. So that tells us we would have the equation x plus 1/2 squared, and then 4 times the p-value. We could write this just to verify that's 4 times 1, and then we have y minus 1. So from this, we can easily then identify the vertex. Again, this is the h, this is our k value. And remember, we're looking at the opposite signs because the original formula has a minus here already. So x plus 1/2, that means our x coordinate, the h, would be a negative 1/2. And the k value over here would be a positive 1. And again, I suggest at this point to draw some type of a rough sketch of what the parabola is going to look like. So we can locate the vertex. Let's see if I mark this off here. Our vertex is going to be located at negative 1/2. So if this is negative 1, positive 1, positive 2, then we're going to go here at a negative 1/2 and then up 1. So here's our vertex. And we know that our p-value here, this is positive. So that tells us that the parabola is going to open up. And this doesn't have to be accurate at this point. We know that it's going to open up something like this, which then that will tell us where the focus is going to be located. We know the focus is going to be the inside, so it's going to be located somewhere here on the inside of the parabola. And we know that's going to be based on the value of p. Well, if p is equal to 1, then that means from the vertex to the focus, we're going to go up 1 unit because that is the value of p. So therefore, the focus is here. And if the coordinates here for the vertex are negative 1/2 and 1, then that means if we're going up, we're going to add the p-value to the y-coordinate. So therefore, we're going to add 1, so that means this point then would be a negative 1/2, the x remains the same, and the y value is going to increase by 1, so therefore that would be equal to 2. So the focus is located at a negative 1/2 and 2. Then of course, if we want to locate the directrix, we're going to go down the value of p. So we're going to go down from the vertex 1 unit. So again, this is p is equal to 1. And our vertex then, directrix is going to simply be right here on the x-axis. So the directrix would fall right through here. And of course, then if this is taking the value of our y, which is 1, we're going to subtract 1 from it. So that means this point here then is going to be 0. So therefore, the directrix would be y equals 0, because remember the directrix is a line, so that means we have to have an equation to represent the line. So here we have a vertex of -1/2, 1, and once we find the vertex, we can sketch the graph to know the parabola is going up, the p-value is positive, and then we know the focus is on the inside, and the directrix is going to be a line on the outside, and the focus and directrix will be p units, in this case 1 unit, from the vertex. Okay, if we look at one more example, we have the equation y squared plus 2y minus 4x plus 33. And this one here is going to be a little bit different because now we notice we don't have our y squared by itself. In this case, we have a y squared and a 2y. So here we have a y squared. So that's going to tell us that our equation is going to have to be horizontal, which means it's going to fit the form of y minus, whoops, not h, y minus k squared equals 4p times x minus h. Okay, so now how can we get this to look like y minus k squared? Well, the first step we want to use over here is we want to get our y terms on the left side by themselves. And of course this here should be, whoops, equal to 0. So then we would keep the y squared, we could keep the 2y, and then we want to move the 4x, so that becomes a positive 4x. We want to add 4x to both sides of the equation. And we also want to move the 33, so therefore we would subtract that, so we would get a minus 33. So now that we have y squared plus 2y equals 4x minus 33, how can we take this y squared plus 2y and rewrite it so that we have some binomial here squared? And in order to do that, we're going to have to use completing the square. So this is where we're going to have to recall how to complete the square. Okay, and we do that by taking, first of all, making sure that the y squared has a coefficient of 1. And if we don't have a coefficient of 1, we have to factor out this quantity. So for example, let me just kind of make something up here. If we had a 2y squared plus 4y, because this quantity is 2y squared, in order to complete the square, we would need to factor out the 2 so that we would get y squared plus 2y. Okay, but in this case, we already have a coefficient of 1. So if we want to complete the square, we're simply going to take our b value, and the b value here is the coefficient of the y. So we're going to take that b value, we're going to take half of it, so we're going to take 2 divided by 2, and then we're going to square that quantity. So 2 divided by 2 is 1, 1 squared is 1. So that means we're going to add 1 here, and that's going to make this a perfect square trinomial. Now, if we add 1 to the left side of the equation, we have to add 1 to the right side of the equation. And by making this y squared plus 2y plus 1, we now have made this a perfect square so that we can factor this to, if you want to think of it this way, y times y, 1 times 1, so it's y plus 1, which means we could simply write this as y plus 1 squared. And that's here to match up this y minus k squared. Now, a quick way to factor this, if you have trouble factoring, once you complete the square, if we simply take half of the b value, remember the b value here is 2, a positive 2 divided by 2 is 1, that's going to give you how this factors. So that's a plus 1 here, so we get y plus 1 squared. Now, on the right side of the equation, we still have this 4x, so that's going to be 4x minus 33 plus 1, so that gives us a minus 32. So now the left side we're in good shape, but now the right side we need to kind of write it so that we have this kind of factored form here. So we have like 4p x minus h. So here, if we go to factor the right side of the equation, uh, we could simply factor out the 4 because we want to get the x here by itself. So I'm going to take out a 4, and that means we're left with the 1x, and that's what we're looking for here, where we just have the x. And then it would be minus, well, 32 divided by 4, if we factor the 4, that would be minus 8. And now we have this form, and we just have to identify what is going to be the value of our p. Well, remember, we take 4p, and we're going to set that equal to the 4 here. So once again, dividing by 4, our p-value is a positive 1. So if it's helpful, you don't have to rewrite this, but that just means we would end up with y plus 1 squared. And we could technically think of this as 4 times 1. And again, it's understood to be a 1, so we don't need to write that. And then multiplied by x minus 8. So now that we have our standard form, from this point, we can easily identify the vertex. And therefore we have, now be careful, this is the x minus 8, so this is the x, so this 4 over here is the h, and we have y plus 1. Remember, this is going to be the k value. So the vertex is going to be positive 8 and negative 1. Because remember, we're going to set x minus 8 equal to 0, so x is equal to 8. And we're going to set y plus 1 equal to 0, so therefore y equals negative 1. So once again, once you find the vertex, this is where I recommend that you look at some sketch of the graph. And we know our vertex is going to be 8, 1. So if I mark that off, so the vertex here is at 8 and then up 1. And our p-value up here, we notice, is positive. So that means our parabola is going to open to the right. So that means our focus is going to have to be on the inside. And if that's the case, then our focus is going to be p units away. So p is equal to 1. So that means we're going to go 1 unit here to the right. And then we would have our focus. And keep in mind, this point is 8, negative 1. So if we're moving 1 unit to the right, that means we're changing the x value. So we're going to add 1 to the 8, and that would give us 9, negative 1. So the focus is at 9, negative 1. And then we could do the same thing if we want to identify the directrix, except for now we know we're going to go the other direction, so we have to go 1 unit to the left, and we would have the directrix to go through here. And if we're going to take 1 away, then the 8 would be 8 minus 1, so therefore we know this is going to be at 7. So the equation would be x equals 7. Okay, so now hopefully you feel a little bit more comfortable with being able to identify the vertex, focus, and directrix once you have written your equation here in standard form. So let me go through this again to review a little bit. The first step is to write the equation in standard form. And in this last example, this was a case where we actually had to use complete in the square so that we have y plus 1 squared. And once we get this in y plus 1 squared, then on the right side over here, we can factor anything out so that we have this x by itself. And then once we have the standard form here, we can easily identify h and k. And then what I would suggest, as we've done here, is identify the vertex, and then plot the vertex, and then figure out which way is the parabola going to open, and then we can easily identify the location of the focus and directrix by using the value of p.